Okay, today we're going to take a look at how to do limiting reactant problems. Limiting reactant problems are different from other stoichiometry problems that we've done before in that rather than just giving you the amount of just one reactant, these problems will give you the amounts of 2 or more reactants that are involved, and you need to figure out what to base your product amounts on. So the best analogy that I can kind of give is something like this. So suppose you want to build cars and you know how many car bodies you have to start with, and you know how many tires. You have 8 car bodies and 48 tires. And the question becomes, well, what is the maximum amount of cars that you can make? So really what you would have to do is you would have to consider each of your starting materials and kind of think about, well, how much product can I make starting with each of these things? So for the 8 car bodies, I can make 8 cars. Okay, for the 48 tires, I can make 12 cars because for each car you would have 4 tires. So it comes to show us that really the maximum amount of cars that I can make are 8. It's the car bodies that are limiting how many cars I can make. It's my car bodies that we would call the limiting reactant. And the other starting material, the other reactant, I would not end up using all of it. I would have some left over at the end of the process. If I make 8 cars and I start with 48 tires, I'm going to end up having 16 tires left over, and we would end up calling the tires the excess reactant. Okay, so one of our reactants is limiting, the other reactant or reactants would be in excess. So we're going to apply the same kind of problem solving technique to a chemistry problem where we are going to take each of our starting materials, each of our reactants, and figure out how much product can I make with each of them. And whichever gives us the least amount of product is going to be our limiting reactant, and the amount of product that I can make from that limiting reactant we call the theoretical yield. So how do we solve these limiting reactant problems? We are going to take each starting amount of reactant and turn it into the amount of the same product. And then we're going to compare these two amounts of products. Whichever makes the least amount is the limiting reactant. And the amount of product calculated from this reactant is the maximum product that can be made. And to be fancy, we call this the theoretical yield. Limiting reactant is the reactant that limits the amount of product. The reaction stops when all the limiting reactant is consumed. So at the end, you have 0 left over. This is what's governing the theoretical yield. It's what's governing the maximum amount of product. And the other reactant is called the excess reactant. It's the reactant that's left over or that remains when the reaction stops. It's not completely consumed. It will still be in the container. Okay, so the best way of really just looking at this, because some of these definitions can get all tangled up, is really just looking at an example. So take a moment and look at this example. What you'll notice is that what's different from other problems, if I give you enough information to have moles of each reactant. In this case, I give you the moles right away. In other problems, I might give you grams, which you could then mole out. But you have the starting amounts of both reactants. And I need to know how much water, which is the product, can be produced. So I don't know which reactant to base this off of yet. Is the 10 moles of H2 going to get completely used up? Is the 7 moles of O2 going to get used up? Which is going to limit my reaction? So what I'm going to do is my plan is I'm going to take the 10 moles of H2, the 10 moles of hydrogen gas, and I'm going to do out almost like one stoichiometry problem, just converting the 10 moles of hydrogen gas into my product. Okay, and then I'm going to do the same exact steps, except I'm going to be starting with 7 moles of oxygen gas, turn that into my product, and I'm going to see which starting material gives me the least amount of product, and whichever does is my limiting reactant, and whichever is my limiting reactant, that's really going to guide how much product I can make. What's the theoretical yield? In this case, there's only one product. So I'm going to turn each of these starting materials into water. If there were 2 or more products, you can feel free to turn them into, you can pick one of the products that you want to turn it into. Just make sure you pick the same product. Okay, so I'm going to take my 10 moles of hydrogen gas, find it in my reaction, here it is. As long as I'm in moles, I can go ahead and do stoichiometry, meaning I can use the coefficients to change from one substance into another. So I want to change the hydrogen gas into water, so I am going to do stoichiometry here. There's 2 moles of hydrogen gas producing 2 moles of water according to my reaction here. And the moles of hydrogen gas are going to cancel out, and I'm in moles of water. Since they asked me in the problem what's the mass of water, I'm going to take this one step further, and I'm just going to change from moles of water into grams of water. And if you need more help how I'm getting these numbers, what I'm doing here, go back to my video about mole conversions and stoichiometry so that so I don't have to repeat myself here. Okay, and really here I'm just massing it out. I'm changing from moles into grams of water. Okay, and in my calculator I get my answer, or in my head I can do this as well. I get that there's 180 grams of water produced, starting with 10 moles of hydrogen gas going through this reaction. Now, I don't just start with 10 moles of hydrogen gas. This is a limiting reactant problem because I see that there's more than one starting material amount given. So I've got to now take the 7 moles of oxygen gas, and in a separate stoichiometry, I'm going to convert that into product. Just like how we do with the cars, we're taking each starting material, turning it into product, and we're going to see which gives us the least amount of product. That is what will limit us. Okay, so I'm going to take the 7 moles of oxygen gas. I'm in moles already, so I can go straight to my coefficients, and in a stoichiometry step, I can convert moles of oxygen into moles of water. Okay, and let's mass it out since they asked for a mass, which I really don't have to. I could just compare mole amounts, but we might as well get into mass right away. And I get that 252 grams of water are produced. Okay, so what is my theoretical yield of water? Well, that would be the smaller amount. Okay, this is the amount of water that theoretically is the maximum that could be produced. And that the 10 moles of H2 is actually my limiting reactant. The 7 moles of oxygen would be in excess. Okay? So just remember, even though it says a lot of times we want to pick the bigger amount, it's really the smaller amount. That's what's limiting you. That's the most that you can make. Okay, I don't have enough hydrogen gas to actually react with all the oxygen. I'll never get up to 252 grams of water. Take a moment and try this example. Notice in this example, I give you grams of each reactant. You have to mole them out first before touching those coefficients. So answer this question: which is the limiting reactant, and what is the theoretical yield of NH3? Okay, so again, this is a limiting reactant problem because I give you enough information to mole out each reactant. 16 grams of hydrogen and 40 grams of nitrogen. So I'm going to take each of those amounts. I'm going to do almost like separate stoichiometry problems to turn each of those into the product, in this case ammonia. And I'm going to see which one gives me the least amount of ammonia. Okay, so it's stoichiometry. Since I'm starting with grams, when in doubt, we mole it out. So we got to be in moles to touch these coefficients in order to change from reactant to product. Okay, so I first got to use the molar mass of H2. There's 2 grams for every 1 mole. Okay, I'm moling it out. Then I can convert from hydrogen gas into ammonia with stoichiometry, 3 moles to 2 moles. Okay, I want the H2 on the bottom so that it cancels out. Now I'm in moles of ammonia, but since the problem asked me for a mass, I might as well use the molar mass and convert this right away into mass. Again, I could have just stopped here and gotten a number, and I can compare mole amounts as well, but since it asks for mass, we might as well use 17 grams for every 1 mole, and we get that 90.7 grams of NH3 could be the maximum produced if I start with 16 grams of hydrogen. Okay, assuming that I would have enough nitrogen to react with all this. Well, let's see what I would get starting with 40 grams of nitrogen. Let's figure out how much product I can make here. So again, I'm in grams, so let's mole it out. Okay, using 28 grams per 1 mole. Nitrogen's diatomic. It has a subscript of 2, so don't forget that the molar mass will be 28 and not 14 here. Okay, now I'm in moles of N2. Now I can convert from moles of N2, nitrogen gas, into moles of ammonium with a 1:2 ratio. Okay, and since they're asking me for mass, might as well mass it out. And now I get that 48.6 grams of ammonia could be produced. Okay, again, just make sure that once you get your product amounts, you're in the same product and the same units. So let's see, what is my limiting reactant and what's my theoretical yield of ammonia? Well, my limiting reactant is the reactant that produces the least amount of product. So my limiting reactant would be the N2, the nitrogen gas. And my theoretical yield of ammonia, my most amount of product that could theoretically be made, is 48.6 because this is the smaller amount here. Okay, take one more moment and try this example and then check your work. Okay, so again, I'm going to take each reactant and turn it separately into a product. And notice here I have 2 products, so feel free to choose either one to figure out what's the limiting reactant. Either turn them both into CO2 or turn them both into H2O. Okay, so pick either one. So here I'm going to turn the C3H8 into, I'm going to choose CO2. Okay, I got to mole it out, then use the coefficients, and then turn it back into the mass of CO2, since that's what they asked for. And I'm going to do the same thing for O2, mole it out, use the coefficients to turn O2 into CO2, and then mass it back out. Okay, and again, you don't have to do this last step here. You can compare moles of CO2 to moles of CO2, but since it asked me for grams, I might as well do that. And what I'll notice is this is the smaller number. C3H8 produces, if all that was used up, I get less CO2 than if all the O2 was used up. So it's the C3H8 that's limiting the reactant. So 60 grams of CO2 is my theoretical yield of CO2, and C3H8 is my limiting reactant. O2 is in excess. It's my excess reactant. It's not limiting. Okay. Now if they ask me for the theoretical yield of H2O, the other product, I don't have to do 2 steps again. I know that C3H8 is my limiting reactant, so if I want to know how much H2O is made, my other product, I just have to turn the 20 grams of C3H8 into H2O instead. I don't have to do 2 separate stoichiometries again and see which is less, because I already know what's limiting. If it's limiting for one product, then it's limiting for the other as well. Okay, so to get the moles of H2O, I'm going to mole out the C3H8, use stoichiometry to turn C3H8 into H2O, and then mass it back out, and I get 33 grams of H2O.